Time series forecasting has been a core part of logistics planning for decades. In both commercial and defence environments, it has helped organisations forecast demand, plan inventory, support maintenance activity, and improve supply continuity. For a long time, it was the backbone of sensible, structured planning. But the world has changed. Today's supply chains are operating in a far more complex, volatile, and unpredictable environment. AI and machine learning are now offering new ways to process larger volumes of data, identify patterns earlier, and support faster decisions. So the real question is not whether traditional forecasting is dead. The real question is whether it is still enough on its own. This presentation explores that challenge through a defence and logistics lens. The key idea is simple. Forecasting is evolving. Traditional methods still matter, but organisations now need to think seriously about how AI and machine learning can augment, strengthen, and improve decision-making. For many years, time series forecasting was the standard approach to demand planning. Methods such as ARIMA, exponential smoothing, and Holt Winters helped organisations analyse historical demand patterns and project future requirements. In stable, reasonably predictable environments, these approaches worked well. In defence logistics, they supported planning for fuel, food, maintenance cycles, and spare parts. In commercial settings, they helped manage replenishment, inventory, and routine demand. The strength of time series forecasting was its simplicity and structure. It was based on historical patterns, easy to understand, and often easier to explain than more advanced analytical models. But those methods depend on one important assumption, that the future will broadly resemble the past. That assumption is now under strain. So while traditional forecasting played a vital role, and still does in some contexts, its limitations are becoming clearer in a world shaped by disruption, volatility, and rapidly changing demand patterns. Modern supply chains do not operate in stable conditions. They operate in a world shaped by geopolitical disruption, rapid technological change, climate-related pressure, and unpredictable demand shocks. Conflicts, trade disruption, and contested logistics routes can affect global supply. New technologies can alter demand patterns quickly. Environmental events can interrupt transport and supply continuity. And in defence, operational surges can create sudden demand that peacetime models simply cannot predict. This is where traditional forecasting starts to struggle. If the forecast is based mainly on historic demand, then it may miss the signals that matter most in volatile conditions. For example, a military operation, a supply disruption, or a rapid increase in tempo can create changes that are not visible in historical data alone. That means the forecasting challenge is no longer just about projecting yesterday into tomorrow. It is about understanding how external events, operational context, and changing conditions affect what happens next. That is why complexity and volatility are forcing organisations to rethink how forecasting is done. AI and machine learning bring a different set of capabilities to forecasting. Unlike traditional time series methods, which rely mainly on historical patterns, AI and ML can ingest wider and more varied data sources. That might include weather data, market signals, maintenance logs, satellite imagery, social sentiment, supplier disruption indicators, or operational activity data. This allows forecasting systems to do more than just extend past patterns. They can look for non-linear relationships, detect weak signals, and adapt more dynamically as new information arrives. In defence logistics, that could mean correlating flight hours, supplier delays, and geopolitical risk indicators to identify spares shortages before they materialise. In commercial logistics, it might mean spotting disruption, demand shifts, or inventory risk earlier than traditional models could. The benefit is not just more data. The benefit is better insight. AI and ML can help organisations move from reactive forecasting to more adaptive and predictive forecasting, particularly in complex and fast-changing environments. Despite all of that, it would be a mistake to write off time series forecasting completely. Traditional forecasting still has real value. It is often fast, lightweight, and relatively easy to build. It can be highly useful in short-term, stable environments where demand patterns are consistent. It is also more transparent and explainable, which matters a great deal in regulated and accountable environments like defence. Another advantage is that it can work well in lower data contexts where machine learning models may be too complex or may overfit. For example, if demand for bottled water at a forward operating base follows a stable pattern, a simple time series model may be entirely sufficient. So the issue is not that traditional forecasting is obsolete. The issue is that it is no longer enough everywhere. Time series still has a role, especially for steady state demand, simple replenishment, and explainable planning. The future is not about replacing it entirely. It is about understanding where it still works well and where more advanced methods are needed. This is where hybrid forecasting becomes so important. Rather than treating traditional forecasting and AI as rivals, organizations should think about how to combine them. Use traditional methods where demand is stable and patterns are well understood. Use AI and machine learning where volatility, anomalies, disruption, and external influences make forecasting more difficult. That creates a more balanced forecasting approach. In defense, that could mean using traditional models for steady-state replenishment, while using AI to detect anomalies, identify emerging shortages, and better prepare for operational surges. In commercial supply chains, it could mean using simple models for stable products and more advanced analytics for dynamic, high-risk, or high-variability items. Hybrid forecasting offers the best of both worlds. It preserves transparency, speed, and structure where those matter, while also bringing in the predictive power of AI where complexity demands it. The goal is not to choose one side. The goal is to build a better forecasting system overall. This is where hybrid forecasting becomes so important. Rather than treating traditional forecasting and AI as rivals, organizations should think about how to combine them. Use traditional methods where demand is stable and patterns are well understood. Use AI and machine learning where volatility, anomalies, disruption, and external influences make forecasting more difficult. That creates a more balanced forecasting approach. In defense, that could mean using traditional models for steady-state replenishment, while using AI to detect anomalies, identify emerging shortages, and better prepare for operational surges. In commercial supply chains, it could mean using simple models for stable products and more advanced analytics for dynamic, high-risk, or high-variability items. Hybrid forecasting offers the best of both worlds. It preserves transparency, speed, and structure where those matter, while also bringing in the predictive power of AI where complexity demands it. The goal is not to choose one side. The goal is to build a better forecasting system overall. The key message is clear. Time series forecasting is not dead, but on its own, it is no longer enough. Traditional methods still have real strengths. They are useful where demand is stable, where explainability matters, and where data is limited. But in volatile, disrupted, and data-rich environments, AI and machine learning can offer much more adaptive and predictive capability. That is why the future lies in augmented or hybrid forecasting. Organizations that combine traditional forecasting with AI and ML will be better positioned to improve readiness, reduce cost, and strengthen resilience. For defense and logistics leaders, the challenge is not whether to replace the past. It is how to combine the best of both worlds. The organizations that make that shift early are likely to make better decisions, respond faster to disruption, and build stronger supply chains for the future. So the final question is this: are you still forecasting for yesterday's world, or are you building forecasting systems fit for tomorrow?